Hi, it's Sam. Welcome back to the shop. Today we're going to be talking about how to program on the ProTrak KMX software. For today's demonstration, I have a blueprint drawn up. I will reference this blueprint multiple times throughout the video. When I do, I'll pop up a picture of the blueprint on your screen. Notice that our blueprint has 3 straight lines, an angled line, a radius, a slot, and a drill hole. We will be discussing how to perform all of these functions on the Track KMX program. To start, turn on your machine and select the program mode. Like stated in previous videos, we can either input our program name now or we can do it later when we save. Personally, I like to do it when I save the program. So the first thing we're going to do is we're going to go to the beginning of the program. When we do that, you'll notice event 1 is now highlighted red and it asks us to select an event. That means we are on event 1 and we need to select an event to start. I'll pop up a picture of our blueprint now. As you can see, our bottom line is a straight line that's 2 inches long. Because it's a straight line, we'll use the mill function. The mill function takes 2 coordinates and connects them with a straight line. Select mill function. As you can see, it asks us for an X and Y beginning coordinate, a X and a Y end coordinate. It also asks us for a connecting radius onto the next line, a tool offset, a feed rate, a tool number, and whether we want to continue or not. Let's start with our X and Y begin and end points. So our X and Y begin points for this part will be 0, 0. 0, 0 will be the bottom left-hand corner of the part. Since that line is 2 inches long and goes horizontally, we will make our X endpoint 2 and our Y endpoint 0. You can input that data now. Next, the machine asks us if we have a connecting radius. If you look at our blueprints, we do not have a connecting radius there. It is a hard edge. We'll just input 0. The machine now asks us for a tool offset. Since we started with that bottom line and went right, we'll be going counterclockwise around this part. Because of that, we want our tool to be on the right side of the slot we just made. An easy way to think of this is to simply look at the line you're trying to make. Imagine it a fence. Which way are you trying to run around the fence? Clockwise or counterclockwise? For us, we're going counterclockwise. Do we want to be on the left side of the fence, the center of the fence, or the right side of the fence? Again, since we're doing a profile, we want to be on the outside of the object, which means we want to be on the right side of the fence. Select 1 for right side of the fence. Next, it asks us for a feed rate. I like 4 personally. Asks us for a tool number. Since this is the first event, we will enter 1 for our tool number. And the computer asks us whether we'd like to continue or not. Since we have 3 more sides to do, we will go ahead and click continue. Like stated in a previous video, continue will remember coordinates from a previous event to assist you in the next event. So for our next event, we are going to be making that angled line. Now, we need coordinates for that angled line, and if we look up at the top, that line curves into the top line. An easy way to get the dimensions for this line is to look at where the line would go if it kept going straight and intersected with the top line. If you look at that, it would intersect at 3 inches. Since it would intersect at 3 inches, that will be our Y coordinate, and our X coordinate would be how wide we want this entire object to be. As you can see up at the top, it says 3.5 inches. So we will go ahead, since this line is straight, we will make a mill function. And like we stated just a second ago, we wanted our X coordinate to be 3.5 inches. And like talked about earlier, if that line went straight up until the top line, it would intersect with the top line at 3 inches. So that would be our Y coordinate. Next, it asks us for a connecting radius. Since we have that radius seen, we will want a connecting radius. And as you can see, it tells us the diameter of that radius is 1 inch. So our radius would be 0.5, half of our diameter. The machine will now ask us whether we want to continue or not. We'll select yes for continue because we still have 2 more sides to program. At this point, since we have 2 lines, we can look at our program and see what it looks like. Notice we have our bottom line and we have our side line. Our side line does not have a connecting radius yet, and that is because we haven't programmed a 3rd line. When we program this top line, we will then see that connecting radius into that 3rd line. When we go back to our program, we look at the top line. It is a horizontal line going back to x0. Since it's a straight line, we'll use continue mill once again. It then asks us for our x and y endpoints. Our x endpoint will be 0. Our y endpoint will be 3. And that is because the part is 3 inches tall, as you can see on that left-hand side. Ask us for a connecting radius. That edge is a square edge, so we do not need a connecting radius. And it asks us once again if we want to continue. Yes, we want to continue. We have 1 more side. That last side is a straight side, so it'll be a continue mill function. It'll ask us for our x and y endpoint. That will be 0, 0, or origin. We do not want a connecting radius, so that will be 0. And we do not want to continue. This is the end of our profile. Now, if we hit the look button, we can see our part on the computer. Please note that this is not scaled correctly to our blueprint image that appeared on your screen. Now that we have our profile done, we can make our slot and our hole. First, we'll start with our hole. Since our hole is a single coordinate, that will be a position drill. Select position drill and select a single hole or position. It will now ask us for an x and y end. This is the coordinate for the hole. If we look, our x coordinate is 3/4 of an inch, 0.75, and our y coordinate is 2¼ inches. Since this is a separate tool, this will actually be a drill bit and not an end mill, we'll make this tool number 2. As soon as you hit enter, it'll move on to the next event. The next thing we need to do is add the slot that sits on the bottom of our object. Notice that this is a straight slot that goes upwards. Since it's a straight slot, we'll use the mill function. Notice that the left-hand side of the slot sits 1 inch from the left-hand side of the object. The slot appears to be a 1/2 inch wide, which means our radius would be 1/4. If we look in the center of our slot, we can tell that it is 1 1/4 inches from the edge of the part. Since it's 1 1/4 inches from the edge, that means our x coordinate will be 1.25. It will ask us for a y coordinate, and since it's sitting on the bottom edge of the part, we'll enter 0. It'll now ask us for an x end and a y end. Our x end will be the same since it's a straight line, 1.25. And now if you look at the slot, it appears to be 1 1/4 inches tall. Since our end mill will be 1/2 inch, we know that we only have to travel up 1 inch to obtain the 1 1/4 inch tall slot. So all we have to enter for our y coordinate is 1 inch. There will be no connecting radius since this is the only slot. We want our tool to ride right on the center of the line we just programmed, so we'll select 0. We want our feed rate to be 5. Since I'll be using a 1/2 inch end mill to make the profile of the part, and this is a 1/2 inch slot, I'll use the same tool I used on the profile of the object earlier. This means the tool will be tool number 1. It asks me if I want to continue or not. Since this is the only slot, I'm going to say no. Now if we look at our part, we notice we have our drilled hole in yellow here. We have our profile, as made earlier, and now we have this line. That line represents our slot. Since our slot was as wide as our end mill, it was simpler to add a straight slot rather than try to program a 1/2 inch pocket onto that edge. Now I'll display the blueprint on the screen, delete the program, and try it again by yourself. Again, this is what you should end with. Now, once we have the program completed and we would like to run it, we have to do a few things first. To run this program, we need to go back to the home screen. Click your mode button. This is the screen you should be at now. To run a program, we have to go through the setup stages as well. If we click setup, we notice we'll have three things: the tool table, the tool path, and verify part. First, we want to enter our tools, so select tool table. As you can see, we only had two tools used in this program, tool 1 and tool 2. If you remember correctly, tool 1 was a 1/2 inch end mill, so we can simply enter 1/2 inch. We do not want a Z offset or a Z modifier, so we can skip those. And it asks us for a tool type. You don't have to fill in a tool type. I personally like to, so that I remember what it is. This is a rough end mill. We'll enter 3. The next tool is tool number 2. If you remember from our blueprints, it was a 1/4 inch hole. That means we need to use a 1/4 inch drill bit. We can enter this data now. Once you have your tool table set up, simply click return to return to this previous screen. Now it'll ask us for a tool path and to verify the part. If you go into tool path, you'll see the path that the tool will take to make the object. This is different from the programmed object we did earlier. This may not look like your programmed part. That is all right. This is a tool path, not a programmed part. Remember that. If you see the X, the yellow X, that is where your tool will begin. Where another yellow X is where it will end. And then the red line is a quick travel line. When we run the machine, it will start at the yellow X, go on around the outside of the object, and stop at this yellow X. It will then prompt us to check our Z-axis. Once you check your Z-axis, it will rapid move over to the next event, so on and so forth. Click return when you're satisfied. The next thing we can do is verify part. When you click verify part, you'll notice you'll have define stock and make part. The first thing you'll want to do is define the stock. It'll ask us for our X and Y minimum, our Z bottom, our X and Y maximum, and our top. All this is doing is asking for how big of a part are you making this out of. The computer will automatically recognize your part made, and it will make a stock material that is 1/4 inch bigger than your program. If we click return and select make part, the computer will make the part for us and show us what it will look like. If we select show part, it will now mill our part and show us what our end product will look like. You can rotate your view if you would like 90 degrees, or you can change how you look at it 2-dimensionally or 3-dimensionally. When you're done looking at your part, you can click exit. Now that we've defined our tool table and we've looked at our tool path, now we can run the part. You do not have to verify your part before you run it, but it is something that you can do to make sure your part looks correct. To run your part, go back to the mode home screen. Now to run our program, simply go to the run button. When you click the run mode, you'll notice a DRO pops up with start and start event on the right hand side. It is important to note that your machine will start from whatever coordinate that you gave it to begin with. For our part, we told it to start in the 0, 0 corner and make a profile counterclockwise around our object. Since we're starting at 0, 0, it's important to know where your machine is at on your part and to make sure that it is positioned correctly in your vise and on your machine. For us, our machine is zeroed and we are where we need to be. Now, to begin and to run our object, simply click Start. The machine will now prompt you and tell you it is ready to begin and to press Go to start. Simply select Go. The machine will now prompt you to load the correct tool and select the spindle speed you would like. We are doing a dry run, so we will not be turning the machine on. Simply select Go when you're ready. The machine will quick move to the started point and it will tell you to set Z. Once you set your Z to the proper depth, select Go. Your machine will now start the profile of your object. If we click Show Path, off to the side, it will show us the path the machine is taking. Like stated previously, the path the machine takes will be different than what you programmed. The program is the actual object that you want to create. The machine comes up with the proper numbers that it needs to make your desired object. When this machine is done running this program, you will have an object that meets your dimensions to the T. To go back to our program, we can simply select Show Absolute. It will now show us a digital readout of the machine as it's moving. If you'd like to see the path again, simply select Show Path. Notice down here it tells us our feed rate and our override. To increase or decrease our feed rate, simply select the up or down button. The ProTrac KMX only allows you to increase the speed up to half of the programmed feed rate. You can decrease the feed rate as much as you would like, however. If we click Show Program, it will show us our program as the machine's working. This allows you to quick reference numbers if you need. Again, you can go back to your Show Absolute to see a digital readout or Show Path to see the tool path. While the machine is running, always remember to watch your part and make sure that you're not going to have any collisions or errors. Notice our machine is now coming to the end of this path. When it gets to the end, it will automatically stop and it will ask you to check Z. Once you check your Z axis and make sure that it is clear, you can select Go and the machine will now prompt you to load the next tool. Once you've loaded the next tool and you've changed your spindle speed to the correct speed, you can select Go. The machine will now rapid move to the next point. Once it's at the next point, it will tell you to set Z. Since this is a drill hole, all you have to do is drill your hole and come back up to the top and you are ready to move again. Note that when you click Go, it will rapid move to the next hole. Notice, since we have a tool change, before it moves, it prompts you to change the tool. Once you change the tool, select Go, and it will now rapid move to our next slot. Set your Z and select Go. Once you've made it to the end of your program, it will prompt you to check Z one last time. Make sure your Z axis is clear and select Go, and it will now tell you that your run is over. If you'd like to restart the program, you can do this by simply selecting Start, and it will restart the program so you can rerun it. When in run, you can also start at an event number. If you just needed to drill your hole deeper, for example, you can do that by starting at that event number. That event number was number 5, so we'll select Start Event Number. We'll enter our event number, number 5. And notice up at the top, it'll tell you that it's a position drill and we're on event 5. It will then tell you we're ready to begin and press Go to start. Select Go, it'll tell you to load the correct tool and to select the right speed. Once you do this, it will rapid move to the Z point, asking you to drill the hole. If you notice, when you start at an event number, it forgets the previous events. This means that you will not see the tool path for the previous events. Once you've drilled your hole, the machine will now prompt you to clear your Z axis because it is getting ready to move to the next position. Select Go, and the machine will now prompt you to make the next pass. If you want to stop where you're at, simply select Stop up at the top or select Mode. This will get you out of the run and take you back to the mode home screen. Now that you've practiced programming, setting up, and now running a program, let's show you how to save that program. Select Program in Out, look for the Save button. Once you click the Save button, it will prompt you to enter a program name. You can do this by either using the alpha matrix or by using a keyboard plugged into the back. we will select the alpha matrix and we will enter some random letters just for an example. Once you have your name here up at the top, you can simply hit end. Notice our name now appears down at the bottom, and now you can click save. Now, if you were working on a project and needed to take a break, you can hit save temp, and that will remember where you are and what you've programmed temporarily. When you come back to the machine the next time, the machine will remember the program and what you were doing before you left. Typically, I like to just save for real, so I will click the save button. Now, if I look, I'll notice that program is in my file names. To return to the home screen, simply hit the mode button. Now we're back at the home screen. Today you have successfully programmed an object, set it up, and ran it. In our future videos, we'll talk about how to use the arc, pocket, profile, and subroutine functions. Can't wait to see you next time.